Up until now, we've been talking about different types of long-term memory, such as episodic, semantic, and skill memory. But long-term memory is just one part or stage of the entire memory process. So in this chapter, we'll learn about short-term memory, which plays an important role in transferring information into long-term memory. We'll discuss the difference between short-term and long-term memory and the connections between them. But first, if we look at the Atkinson and Shiffrin model of memory, we see that when we perceive sensory information, it first enters into sensory memory. Then the information that we attend to is transferred to short-term memory and ultimately to long-term memory for permanent or near permanent storage. So sensory memories are brief, transient sensations of what you have just perceived. You can have sensory memory for each of the senses like visual, auditory, touch. So it was once believed that sensory memory was extremely limited in terms of storage space, that we could only hold a small amount of sensory information within this sensory memory system. This was based on free recall memory performance for very briefly presented visual information. So let's try a sensory memory test. So I'll show you the next slide for only about 1 or 2 seconds. And you try to process and remember as many letters as you can. Okay, so ready? All right, so now think of how many you can remember. So this was the type of test that participants were given, and research suggests that in this type of test, recall performance is only about 30 to 40% of the letters. So in our test, approximately 3 to 4 letters is all that most people remember from the list. So this was taken to mean that sensory memory was really constrained in terms of capacity. So does this mean that the capacity of sensory memory is only a maximum of 4 letters? Well, research by Sperling in the 1950s and the 1960s suggests that rather than being limited in terms of capacity, sensory memory is limited in terms of time, that we can theoretically store a large amount of information in sensory memory, but only for a very brief amount of time, only for about 1 to 2 seconds. So by the time you report 4 letters, 2 seconds has passed and the other letters have faded out of sensory memory. So they were there, they just disappeared before you could report them. So how did Sperling demonstrate this? Well, participants were asked to only report 1 row of 4 letters, but which row they reported would depend on the sound of the bell. So they would receive the same test that you guys got, but then when it came time to recall, to write down all the words they remembered, they would be specifically instructed to report letters from just one of the 3 rows. So for instance, if they heard a soft bell, or kind of a quiet bell, they would report the first row, kind of a medium in loudness, they would report the middle, and a really loud bell, they would report the last row. So while in free recall, maybe you only reported the first row, this X, E, G, K, we might think that that means you only stored that first row of letters. But in this test, we would find that you could report that last row of letters when instructed by the bell to start with that row. Right? So again, suggesting that sensory memory is limited in terms of time rather than capacity. So sensory information is attended to. It can be transferred to short-term memory for further processing and somewhat longer storage. However, as the name would imply, Short-term memory information is only held for a brief period, about 1 minute, unless one engages in active maintenance strategies to hold that information in there for a longer period of time. We have to consciously maintain information in short-term memory through rehearsal or some other means, or we lose it. So short-term memory only holds the information that we are currently cognitively processing. The classic example of this is, let's say you look up a phone number to Pizza Hut on your computer, and then you realize that your phone is in the other room. So if you want to get up, walk, get your phone and dial as soon as you get your phone, then what do you do as you are walking to the next room? Most of us will rehearse that number. We'll repeat it over and over again as we're walking to get our phone to make sure that we don't forget it during that period of time. So we're going over and over again, 817-254-5567, 817-254-5567, over and over again until we get our phone and then we type it in, right? Now, what happens if along the way your kid or your husband, wife, or roommate asks you a question or says something to you to distract you from rehearsing that number? Most of us forget it. Right? If we're not actively rehearsing it and maintaining that information in short-term memory, if we're distracted and our attention is displaced elsewhere, then we lose that information that we were trying to hold on to in short-term memory, unless it is transferred to long-term memory. But unlike long-term memory that is thought to have kind of virtually unlimited capacity, we can only hold a small amount of information in short-term memory. The capacity of short-term memory is typically measured through what's called a span test. And so very often it's a digit span task. It's used to determine an individual's short-term memory capacity. So participants will hear a series of digits and be asked to repeat them back. And with each trial, the number of digits gets longer, right? You add more digits. So I may start by saying out loud 5 and ask you to repeat that back to me, right? Surely you could remember 1 digit. I may say 2, 6, and ask you to repeat that back to me, 2, 6. Then say, okay, 4, 1, 7. You repeat back 4, 1, 7, so on and so forth until you make a mistake, right? Until the number of digits gets so long that you can't remember all of them. So maybe we get all the way to the end of this list here. I say 1, 9, 3, 8, 5, 2, 7. You're asked to repeat back to me 1, 9, 3, 8, 5, 2, 7. So this entire list of numbers in order as you heard them, right? Repeat them back to me. So the longer the list, so the longest list that can be reliably repeated back by the participant is his or her digit span. And so short-term memory capacity is typically around 7 digits. So Miller in 1956, using this technique, found that the capacity of short-term memory is approximately 7 digits plus or minus 2. So this is sometimes called Miller's magic number. This seems to be a biological constraint that short-term memory can only hold around 5 to 9 pieces of information. And so think about why our phone numbers are 7 digits. It fits in with this research, right, of Miller. And so you may ask, well, what about people who seem to have extraordinary memory abilities?
Reigning world memory champion Wang Feng stormed to victory at the 20th annual World Memory Championships in China on Friday, slashing world records in his wake. The 21-year-old student smashed the world record for spoken numbers, recalling over 300 out of 400, beating the previous record by over 100 digits. I've spent 3 months preparing for this championship, and each day I spend 5 to 6 hours practicing. Actually, each year I spend 2 to 3 months to prepare for competitions. Over 3 days, more than 120 competitors aged 9 to 74 participated in 10 separate memory disciplines testing speed and endurance. Among the challenges, competitors memorized 30 packs of playing cards in an hour, 3,500 binary numbers, 400 numbers spoken at 1-second intervals, put over 90 names to faces in 15 minutes, and memorized a single pack of cards in under 30 seconds.
So we see individuals who complete and compete in these competitions. And so what does that say about our research that suggests that there's a limited capacity of short-term memory? What is happening with these individuals? Are they maybe biologically different? Is their brain, their central nervous system different from ours that allows them to engage in these kind of extraordinary feats of short-term memory, instead of really changing that biological constraint of 5 to 7 digits or 7 to 9 digits. What seems to be the case is that, as the individual mentioned, he practiced and prepared for months. So these individuals train and develop strategies that allow them to make better use of this limited capacity. And so rather than being 5 to 9 digits, instead, the short-term memory capacity seems to be 5 to 9 pieces of information. So if individuals can develop strategies to repackage information to make more efficient use of this limited storage space, then they can engage in these really impressive short-term memory tasks. So it's not as though they are changing and that their short-term memory is unlimited. They're just making better use of that same limited capacity that you and I have, right? Through what's called chunking or kind of repackaging of information. And so, for instance, if we can take 708 and repackage it into 708, right? If we can repackage information into meaningful units, then we could make better use of that storage space. So I could think 1492, or I could think 1492, right, as a meaningful date. And now I'm taking these 4 digits and repackage them into one. Between short-term and long-term memory. So short-term memory just contains the information that is currently in your active consciousness, right? What are you processing at this particular moment? Versus long-term memory as a storage space for all of your episodic autobiographical memories, right? All of that semantic knowledge that you have acquired over a lifetime that you may not be consciously thinking about in this particular moment, but you could retrieve that information and use it if you wanted to. So with access for short-term memory, because you are currently processing it, access to this information is very rapid, versus access to long-term memory may be a bit slower. If you've ever had to maybe think for a minute to recall the name of someone that you met months or years ago, right? It may take you a while to retrieve that information from long-term memory. The capacity of short-term memory is limited, whereas as far as we know, the capacity of long-term memory is virtually unlimited, right? You can store a lifetime of information in long-term memory. And you can store it for a substantial period of time. Whereas with short-term memory, as we said, if you are distracted, if you're not consciously processing and attending to this information, then it very rapidly decays, right? You lose that particular information. So check out the next video in which we'll talk about the serial position effect or the serial position curve.